All right, we're live. We're back. My name is Sunny. This is the Sunny Ray Show. Thanks to our sponsors, GTM Ventures and Raz Rocket. Today, I'm joined by Rowan. Rowan, how you doing?
I'm doing well, Sonny. How are you?
I am well. As you saw, I'm enjoying a burrito.
It's good,
Rowan,
man.
why don't you kick us off by just sharing like a sentence or two about your company, and then we'll come back to that near the end of the interview. But I like to kind of give people a little sense of what you're building today right off the top.
Yeah, so at Helix Earth, we're using technology. We're actually adapting a technology I developed at NASA. It's a new type of filtration system that we can use to affect a bunch of different kinds of liquid gas chemistry processes. What we're using it for is actually to develop retrofit hardware that dehumidifies air before it gets to air conditioners. And in that way, what we can do is we can save tons of energy for air conditioners and also solve a bunch of problems for buildings around the world. So essentially, it's what we do, but there's a bunch of other applications that we're also pursuing alongside that.
Very cool, very cool. So let's maybe take a step back. I was quite interested. So you said you spent time as an engineer at NASA. So maybe take us back to that. So what was the single biggest like culture shock when moving from an agency with infinite precision to kind of the move fast and break things world of startups?
Yeah, that's a really good question. Actually, no one's asked me that in particular. I guess one thing that's like a stark difference is, in a big organization like that, having an entrepreneurial mindset and like moving fast, breaking things can get you in trouble. It did at least a couple times for me. So you're kind of discouraged from doing that, right? But in a startup, as you know, it's like the opposite. You want to move as fast as you can, make as many mistakes as you can early, upfront, and learn as much as you can so that you can move fast. So I'd say that's like the biggest difference, going from a big bureaucratic organization where essentially you're just protecting from downside risk. You're just protecting from making mistakes. Here in a startup, you wanna make as many mistakes as you can because it's more like upside oriented, right? So that's the major difference, I would say.
I talked to like maybe 15, I don't know, 20 entrepreneurs a day. And, the fact you have a PhD is quite unique. So I was curious, how does a PhD background actually help a founder? And does the kind of like the academic rigor ever get in the way of making fast business decisions?
That's a good question. So, you know, where the PhD definitely helps, it gave me the kind of the bandwidth and the time to really start to explore different ideas. Because what I was doing in my PhD is I took that NASA filter, I took it to be part of my PhD research and dissertation, and I did a bunch of experiments around that to understand the technology, to understand its applications. So my PhD was a great place to start doing some early experiments to understand, hey, where could this technology actually work? And we had entrepreneurial programs at Rice, which is where I did my PhD. Lily is one of them, is what it's called. And so there they gave us like some little bit of money to go and pursue some ideas and help us do the basics of entrepreneurship, like how do you talk to customers, how do you do a pitch, right? Those kinds of things. So really, the PhD for me was a great place to start to experiment and do that in a very low risk environment. And then I would say beyond that, like the rigorous process, the scientific method, because I have a PhD in engineering, so we're taught the scientific method, is really nice for kind of continuously improving and like iterating your way to success. So that framework's really great. And then also in a PhD, especially in a science focused one, you really are taught. It's people don't necessarily maybe think about this, but you're really taught how to communicate. How do you articulate very complex concepts in a way that everybody can understand, but then also to get them excited and to go deep. That's like the communication skills, both written and verbal, was really, really harped on, especially by my group. And so that whole skill is really what helped me go and raise funding, right? As a first time founder, as a CEO of my company, I'm going out raising money. I'm pitching to investors, and the same skills I learned, sort of talking about my research, pitching that, and then defending it, because you have to defend it from sort of criticisms and questions. Those same skills transferred over almost seamlessly to raising money and talking to customers and selling my ideas and selling our products, right? So that was really helpful. I think where the PhD can be detrimental is kind of what you said. It's like analysis paralysis is kind of the big thing that you have to guard against. But then also, kind of stepping away from the technical side in my company, I have to kind of I kept trying to like hire myself out of the technical duties day to day, because there's other things you have to do as a founder, as a CEO. So I find that some people have a hard time kind of letting go of the day to day engineering or technical work, because you're usually, in the beginning at least, the best at it. Now I'm verifiably like the worst at it on my company, which is a good sign in my mind. So kind of stepping away from that is it can be a challenge, and then also making sure that you can be quick, make quick decisions, and that can be a challenge. But for me, that was never really a big issue. But I know that other sort of PhD founders like me can have that issue, that challenge. So it's small mindset tweaks that you have to make. But otherwise, I found that the PhD, for me at least, gave me a really good base and a really good background for some of the challenges I would face as a CEO.
Yeah, that's super interesting. So what was the most complex technical problem you solved while at NASA? Then I promise we'll move off the NASA questions.
Yeah. Oh man, interesting. Well, there was so I would say like the first thing I did actually, and the first thing I did was I ended up being the first in the state of Oregon to receive a space technology research fellowship, is what it's called, from NASA. That's what led me to eventually get a job there. But as part of that fellowship and as part of my collaboration there, we had to come up with a new method for doing distillation. So essentially, like separating water from dirty water. So purifying the water in a distillation manner. I can explain that in a sec. There's a horrible description over there. But essentially, in space, what you have to do is you have to take the water out of urine and re-drink it. We say yesterday's coffee is today's coffee. It's kind of gross, but that's what you got to do. Urine is like 98% water. So if you pull that out, you can actually purify it and throw all the junk away, and you get left with just pure drinkable water. As you can imagine, urine's kind of gross, so it fouls, surfaces foul, creates a lot of kinds of bacteria, and so it's really hard to do. And the systems that do that are pretty expensive and costly, and they require a lot of upkeep because of the sort of the nasty nature of the biologically active liquid that urine is. So the first thing I did with NASA was actually to figure out a way to distill the urine. So in other words, separate the pure water from all the nasty stuff. How to do that without ever touching surfaces. So I ended up patenting that idea and ended up getting some government funding to do a proof of concept of it. But I would say that was like the most challenging thing, because it combined practical engineering or a practical system with emerging science. So we had to use emerging science to develop this new process, which was probably the hardest thing I did, actually.
Cool. So let's maybe shift gears and talk a little bit about kind of the aha moment that, when you shifted gears and decided that you'd build a company, right? So was there kind of like a specific day or like a failed experiment where you realized, okay, this technology needs to be a company, not just a paper?
Yeah, I would say it was more like a journey, but there were like a couple of really good, like solid proof points for me. One was for my PhD, the Department of Energy, actually, I got a fellowship from the Department of Energy to pursue my PhD. And what I proposed, the way these fellowships work is that you propose an idea. Hey, I'm proposing this idea. Here's what I want to do. You have to kind of show the merit, the problem, the solution, like kind of like pitching a company, right? The DOE ended up funding that and funded my PhD. And the whole proposal was around what we're doing today at Helix Earth, which is using this NASA technology to minimize air conditioning energy usage. And when I got that, it was like one of the check marks, like this is a real problem. This is a real thing. We should definitely pursue this. And then the second biggest moment was the first startup competition I ever entered, which was like the local competition at Rice. There was about 84 teams that competed. Grand prize was like 35,000. I entered like at the last minute, and then went through the few stages, made it to the finals, and then like won first place. And so that moment I was like, oh crap, like I can actually do this, and I have some money now that I can, do some basic things with it and start to get off the ground. And so it was like those two moments kind of came together, and I was like, this is something I'd be dumb not to pursue it. There's no downside. I just have to quit my job, which is like, was not an easy decision, but like those two moments were like really big for me to sort of just double down and commit fully to it.
Wow, that's super inspirational. So, in plain English, can you describe like what is the impossible problem that Helix Earth is solving better than anyone else in the world?
Yeah. So the thing with air conditioning is that some of the energy that your air conditioner uses goes into dropping the temperature, and then some of the energy goes into pulling the humidity out of the air. So physics just demands you have to pull the humidity out. So if you've ever seen like a window air conditioner with water dripping out of the back of it, that's the humidity being pulled out of the air. And in some of the worst climates, here in Houston for sure, that's where we're based, but even up as far up north as New York, in the U.S. at least, that humidity component of the energy use can account for 70 to 80% of the energy used by the air conditioner. It's a huge load on the air conditioner, and the technology hasn't really changed for the past 60 years. So what we do is actually we dry out the air before it gets to the air conditioner, so that we can eliminate much of that load from the air conditioner itself. We actually help the air conditioner operate a little bit more efficiently than it otherwise would, because now it's not dealing with all of this moisture. So that's the process that we've developed, and the way we've developed it with our NASA technology is we're like 5 times smaller than any other process that's out there. So that means we're cheaper to produce, we're cheaper to build, easier to install, we can fit in places that no one else can. And really our whole premise, our whole value prop to the customer is that this is a bolt-on. It bolts onto virtually any of your existing commercial air conditioners, given that they're in the right size range. But bolts onto your existing infrastructure, you don't have to change anything, and you get capabilities and savings on your air conditioner that you didn't have before.
And how are you balancing kind of this PhD's need for technical perfection with the startup MVP, minimum viable product thing, like as you're coming to market and all that?
Yeah, I mean, as you know, it's like you basically just need to iterate your way to perfection. And I would say actually the PhD doesn't necessarily teach perfection in the way you think it does. The way that the scientific method works too is just like, let's try simple experiments, let's do something very simple, build out a theory, and then let's build on that little by little, right? Very much similar to what you do in a startup. So like for us, it was, let's build something at 1/10 the scale, then let's go to half the scale, then let's do full scale, and then let's optimize that full scale system. So it's just like stair stepping your way to a better and better solution. You're never going to have the product that you want at the end of the day, because like everything at the end of the day is a compromise, right? But if you just keep on improving, little by little every day, then you will get to a product that is really good, that it can do a lot of unique things, that solves a lot of problems for customers. So that's kind of the mindset that we've embodied, and I've hired a lot of really good startup people, so folks that have experience in startups and scaling, going from zero to a full product, right? And so they've helped with kind of instilling that mindset as well, not only in the culture of the company, but also with me as well. So it's really about building that community as well. That's a really big thing.
And then for the engineers and researchers watching, why is now the best time in history to leave the lab and start a company?
Well, I don't. That's a good question. I mean, I don't know that now is I don't know if there's ever like a perfect time to do anything. So I'll just start it off with that way. Like I don't think there's ever a perfect time. Like you hear this with personal things. Like there's never a perfect time to get married. There's never a perfect time to have kids. Like I don't think there's ever like a perfect ideal time. There are better times than others, right? But like what I think right now that we're feeling as a society is like energy prices are going through the roof, right? It's continuously for the past 5-6 years has been going up, and it's projected to continue to go up. So energy prices are rising. We're spoiled here in the U.S., but around the world, energy is really expensive, especially in Europe. You think about it, it's like 2-3 times more expensive than here in the States. So energy's going up in price. It is a scarce resource at this point. So that's a problem. And then just our climate and our environment. Like now, what we're seeing is that the rest of the world is coming onto the energy grid. So by 2050, actually, the just cooling spaces is going to account for 8% of global CO2 emissions. So that's going to be more than the aviation industry and the passenger vehicles on the road combined. huge hit on like how much energy we use, how much CO2 we emit, and it's all just from air conditioning. It's all from cooling our spaces because now much of the developing world's coming onto the energy grid. And what do they invest in? They invest in food, they invest in healthcare, and then third, they invest in comfort. So, and the comfort is for most parts of the world, I need cooling. I need my space cooled and air conditioned. And then once they get on that, they never go back, right? So that's like a big deal. And then also the world's getting hotter. You know, it's getting hotter every single year. Heat-related illnesses and deaths are going up through the roof. And so we just need to make air conditioning, you know, less impactful on the environment, cheaper to not only purchase but cheaper to operate. So all these kinds of things are coming together that makes sense now to really be thinking about these things, because like I mentioned, base technology has been the same for about 50 years, even longer than that actually. So you know we think it's time for a change, and more importantly, our customers are definitely dying for a change because there's a bunch of things that we can solve for them that they don't have access to solutions yet. So,
Well, I mean, having visited India like since I was a kid and living there as an adult as well, like I can definitely attest to the fact that yeah, there are definitely parts in the world where AC is like an absolute necessity, and even in places like Canada in the summertime, like you wouldn't be able to get by. So, cool, man. Well, thank you so much for your time, Rowan. That was really interesting and a little bit outside of my lane in terms of where I normally focus, but nonetheless, innovation happens everywhere. And so thank you for sparing your time, and don't work too hard on the weekend. Thank you all for tuning in, and I'll bring this one to a close. Maybe hang out for 1 second, Rowan.